For the following exercises, use the rational zeros theorem to find the real solutions to each equation. So we're going to take a look at number 23 there since it's underlined. We're going to look at that one. So how the rational zeros theorem works is we take the function, and I'm just going to call it f of x here. It doesn't matter if I do or don't, but that's 2x cubed plus 7x squared minus 10x minus 24. And what we're going to do here is we're just going to try to find the zeros of it. So that means my p then, and if you look at where this is coming from, it comes from here, problem I did previously. So I just kind of set this up right now here, the f of x. And now I'm just going to examine my p over q. So I have a p here, and p is a factor of a naught. And my a naught is over here on the end. So I'm just starting there. So then that means my p is going to be a factor of 24, negative 24. So I'm going to say plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus, plus or minus 8. I had a hard time writing that one. No 9, no 10, no 11, no 12, plus or minus 12. Yep, 12 works. And then plus or minus 24. Whoa, that's a whole lot of factors. And they're all pretty bad for this one. This one's 18, this one's 24. I think the shortest list would probably be the number 24 there. Whew, a lot of p's. So then for our q, again, I'll go back to the theorem here. Here's the theorem. So for our q's must be a factor of a naught. And that an, excuse me. And an is the leading coefficient. All right, so now we go there. So for our q's, it's going to be for the 2. So that's nice. Plus or minus 1, plus or minus 2. Now I said in a previous video that the plus or minus 1, when I divide it underneath of each of those there, that it's not going to make a big difference. It'll give me the same list, both the plus and the minus, or the positive and negative. So I'm just going to make a list of my p over q now. And that would be plus or minus 1. Actually, you know what? Better yet. It's just going to be all of these when I divide it by positive or negative 1. So I'm going to copy that, and I'm going to paste it. There we go. So there's all of those, and that's the first part of my list. And it's not all of them. Now I have to take each of these and divide it by positive or negative 2. So that's what I'm going to do now. So that being said, plus or minus 1/2, plus or minus the 2 over 2 is going to give me 1. I was going to say plus or minus 2 over 2, because that's what I would get by taking this now. Not this, I'm sorry. These. Okay, and that's going to give me 1, so I don't need it. So I have plus or minus 3/2. And then if I take the 4 there, 4 over 2, that's just going to give me plus or minus 2, which I already have here, so I don't need that one. And then I look at this one here, and that's going to be divided by 6, which is going to give me 3, which I already have here. And then 4, which is 8 over 2, which is 4, excuse me. And I already have those here. And then the 12 over plus or minus 2. And this is what I'm talking about here. If I take this, this is going to give me a 6. I already have it, so I don't need it. And then the 24 is going to give me a 12. So when I take this plus or minus 24 over plus or minus 2, that's going to give me a plus or minus 12. And I already have that one as well. So this is my list right here. That's all of them. Now what we're going to have to do with this list is we're going to have to plug them in, this P over Q. So these, I'm going to try all of them. And hopefully I find 1. If I find 1, then I can actually divide it out. And then once I divide it out, then I got a quadratic and I can actually factor that one without using any other method but trial and error or AC method, whichever you prefer. So here we go. So I'm going to try f of 1. And I'm just going to plug this in so you can see exactly what I'm doing here. Plus 7, 1 squared, minus 10 times 1, minus 24. So now this is going to give me 2 plus 7 minus 9 minus 20. Oops. How did I get minus 9? Losing it. Minus 10 minus 24. There we go. And we can see that this is not going to be 0. And that's all I'm really looking for here. And if I wanted to write the number down, I could. Not a big deal. That's 34. 34 minus 9 is 25. So, and it's negative. Don't forget my sign. So it's not 0, so I can move on from there. So now I'm going to try a negative 1. So then I make all of those negatives. And then I try that one. And then you will see that this also isn't going to be 0. So I'm just going to continue this pattern until I find one. So I recommend you do the same. And then I get down to f of 2. And f of 2 actually equals 0. So there's my first 0. And then now I'm just going to use synthetic division to make this process a little easier. So I'm going to say, okay, I'm going to have 2 is my 0, so I'm going to put the 2 on the outside. And then on the inside I have the 2, the 7, the 10, and it's negative 10, and negative 24. So draw my line, bring down the 2. 2 times 2 is 4. Write that below the 7. Add those. It's going to be 11. 11 times 2 is 22, so put it here. Add those together, and that's going to be 12. 12 times 2 is 24. Add those together, and I get 0, which I should because when it goes into it evenly, my Rx should be 0. So now I'm just going to write the polynomial for this. So this is going to be 2x squared plus 11x plus 12. And that's my qx. And if I was thinking in terms of factors here, for this polynomial, I would have x minus 2 times 2x squared plus 11x plus 12, and that equals 0 by the original problem here, just factored on the left side. Okay, now what I have to do is I have to go further with this, and I can just factor that. I know right away that one of them has to be a 2x, and the other one has to be an x. Now I have to break it down some more in such a way that my factors of 12, which are, I could do 1 and 12, 2 and 6, 3 and 4, a lot of possibilities here. So I have to get an 11 for my middle term. So that's what we'll have to play around with. Hopefully you've seen that if I do a plus 3 here and a plus 4 here, that would work, because that would give me my 8, and that would give me 3, so that would be an 11. So that breaks down into those two. So now we have everything we need, because we have the x minus 2 here, and we know that all equals 0. So my zeros for this are going to be 2, negative 3 over 2, and negative 4. Because remember, we have to keep in mind, what do I plug in for x to make these all 0? Now, they're not all going to be 0 at the same time, because they're all different factors. But if I plug in a 2 here, this is going to be 0, and whatever these turn out to be, I'm eventually going to times it by 0. So that'll give me 0. So that's why I only have to think about one being 0 at a time. And there's 3 halves, negative 3 halves. Hopefully you see that one now from the last video. And I would just say 2x plus 3 equals 0. And I just solve it for that. And I would see if I move the 3 over and divide by 2, I would get negative 3 halves. So that's our answers for this one here, using the rational zeros theorem. Now again, we only have to use it as far as we need to go. Once we get down to quadratics, which are x squared polynomials, then we can actually do it by AC method, trial and error, whatever process you feel comfortable with.